What we are going to be seeing is doing things better, quicker, faster, cheaper. What's incredibly important to make that process as efficient as possible is collaboration.
And so I think, as we all are trying to look at these really ambitious net zero goals, there's no way to do that without being collaborative.
People often observe that it's misleading to talk about breakthrough technologies because actually more often it's that continuous process of evolution.
Welcome back to Net Zero. What's innovation got to do with it? The podcast where we explore one of the critical ingredients for decarbonising our economies at breakneck speed, innovation. I'm Simon Retallick.
And I'm Nina Foster, and together we lead the Carbon Trust's Net Zero Intelligence Unit, a new independent research team that works to identify and share workable solutions to accelerate progress towards net zero.
Welcome to the second episode in our limited series looking at the innovation needed to reach net zero. In our first episode, we kicked things off with an inspiring conversation with Sir Patrick Vallance. If you haven't listened to that yet, please do check it out. We're moving the conversation on today to focus on how to scale the critical technologies that we've already proven, which will be the bedrock of a global net zero energy system, with a deep dive into offshore wind. Now, you might think it's strange to focus an entire episode on technologies we already have in a podcast all about innovation. Why are we doing that, Nina?
Well, you're right. Often when we think of innovation, we think of new technological breakthroughs, but we know that to achieve net zero, we're going to need vast amounts more of technologies that we already have. But building those technologies out is going to bring huge challenges, and we're going to need innovative thinking and action to overcome them. So from policy to new processes, we'll need new enabling infrastructure as well. And we'll also have to modify some of those technologies so they work in brand new environments. And offshore wind is a great example of one of these technologies that we already have. We'll need vast amounts more of it, but the journey to achieving that is going to be far from straightforward.
To discuss these important topics with us, we're delighted to be joined today by three distinguished guests. Simon Sharpe, Director of Economics at the UN High-Level Champions Team and former UK diplomat and climate advisor. Marine scientist Dr. Lyndie Hice-Dunton, Executive Director of the US National Offshore Wind Research and Development Consortium. Quite a mouthful, that one, but welcome. And last but not least, Megan Smith, Head of Offshore Wind Advisory at the Carbon Trust and Policy Fellow at Cambridge University's Centre for Science and Policy.
Great. Well, it's wonderful to have Megan and not one but two Simons in the room here. But we have Lyndie joining us online. Lyndie, where are you joining us from today?
Well, I am based in the US, so I'm joining from across the pond. So I appreciate the ability to join you all remotely, and unfortunately couldn't be there in person today.
Yes, thank you. I mean, it must be an early morning for you, so we appreciate it very much. So to kick things off, I think it's important to begin by taking a step back and looking at why we need more of these existing technologies. Why are they so crucial to achieving net zero? So to give a sense of the scale, last month, the International Energy Agency said that we can actually achieve 80% of the emissions reductions we need this decade through technologies we already have, like wind and solar. But they crucially said that we need a build big mentality to do that. Simon, I want to come to you first because you've recently written a book about how we need to be cutting emissions 5 times faster than we are today. What does that mean for the rate at which we need to be deploying existing technologies?
Well, thanks. First, I should explain why the 5 times faster. That was in terms of emissions per unit global GDP. If you look at how's that changed over time, over the last 2 decades, then on average, it fell by about 1.5% per year. And if we're going to be on track this decade for limiting climate change to 1.5 degrees, then we need that rate of decarbonisation of the global economy measured the same way to be more like 8% per year. So on that measure, it's 5 times faster. But that's looking across the whole global economy. And of course, that aggregates a lot of things. So it's very useful to split it up and look at how are we doing in terms of different sectors and different technologies. And there you see there's a really wide range. There are actually some technologies where we need to keep doing what we're doing. If you look at electric vehicles, we're doubling sales globally every 1 and a bit years. If we keep up that rate of exponential growth, actually we're on track. Similarly, solar power, keep up the doubling rate, we're not far off a 1.5 degree consistent pathway.
If we set aside this idea that innovation is solely about developing brand new technologies, what is the role of innovation in scaling up those technologies we've already got?
I think it's a continuous process of evolution. If you look at solar power, it's come down in cost by a factor of roughly 10,000 over the last 60 years. Since it was first deployed on a satellite that the Soviet premier called the Grapefruit in 1957, it's fallen by 10,000 times, from something that was so expensive you would only use it in space to now what the IEA calls the cheapest electricity in history. And why has that happened? Well, it's been driven by a process of reinforcing feedbacks. The more we make it, the better we get at making it. The more we make, the cheaper it gets. The more we make, the more other technologies emerge that make it more useful. There's this continuing process of reinforcing feedbacks, continuing evolution. So I think people often observe that it's misleading to talk about breakthrough technologies because actually more often it's that continuous process of evolution. And the crucial thing, I think, for governments to understand is how you encourage and how you drive that process.
Yeah, I'm interested in this idea of it being a continual process of innovation and breakthroughs, because in your book, you introduce this idea of tipping cascades, where one innovation has this domino effect that leads to system-wide change. I wonder if you could explain how that works. Does the initial innovation lead to further innovations or just widespread adoption of that initial technology?
Yeah, sure. And I think this, for me, my interest in tipping points started with seeing the tipping points in the climate system, work by people like Professor Tim Lenton. These ideas people are very familiar with now. 20 years ago, they weren't so much, but things like dieback of the Amazon rainforest and collapse of the Greenland ice sheet. And you actually observe these kind of tipping points in all complex systems. They're places where a small push leads to a very big change and a fundamental state of change in the dynamics of the system. And you see these in the economy as well. You see them in technology transitions of the past. There's a point where suddenly consumers prefer the new technology to the old. The businesses realize they need to make the new one and give up on the old ones. The investors see the same thing. And then you have a real acceleration of change. The interesting thing, as you said, is that you may actually be able to have not only a tipping point in a single sector, but a cascade of change across sectors. Why might that happen? Well, it's because of the technologies that are shared between sectors. So, for example, right now, we are crossing a tipping point in road transport where electric vehicles are becoming cheaper to own over a lifetime than petrol cars. That's happening in the advanced markets. That's leading to a rapid increase in adoption, which of course is scaling up production of batteries, and it's pushing batteries further and further down the cost curve. So batteries are getting cheaper. That's very helpful in the power sector. That brings us closer to the threshold in the power sector where solar plus storage or wind plus storage becomes cheaper than coal or gas. So there's a real cascade of change that can play out there. And for me, that's a good source of hope. That actually suggests that change in the economy could be much faster than we typically assume.
Yeah, so today we're talking mostly about offshore wind, but in a way we should be thinking about what offshore wind enables for many other sectors of the economy by creating a cheap, clean source of electricity.
Yeah, absolutely. It contributes to that process. Yeah.
And these tipping cascades where we could achieve this system-wide change, we've got COP28 coming up. I wonder if you could explain at a high level, what does the international community need to do to achieve that level of system-wide change?
Yeah, well, at a very high level, I'd say we need to shift the structure of climate diplomacy, because for 30 years, the main focus of it has been economy-wide emissions targets. And also it's been a multilateral process involving all countries in the world. That's good in what it's achieved, which is consensus on global goals, but it's not really well set up to drive rapid change in the global economy. To do that, I think we have to change diplomacy in three ways. One is it has to be sector specific, because it's obvious, but each of the sectors is very different from the others. If you want to shift the power sector, it's different from aviation. Second thing is it needs to be increasingly plurilateral, not just unilateral. It's not all about nationally determined contributions. We're in a global economy here. We ought to be working together, but also not 196 countries around the table trying to agree everything, because that way the lowest common denominator is as low as it could possibly be. So you need small groups, and typically top 10 countries account for about 3/4 of production or consumption in a given sector. And finally, it needs to be more action focused, less target focused, because early in the transition, people really don't know what they're going to achieve. They don't have much confidence. Targets tend to be very weak. The best example of this is China. In 2008, they set a target of deploying 1.8 gigawatts of solar by 2020. When they got there, they deployed 252 gigawatts of solar power, 140 times as much as they expected. So actions are where the leverage is. Actions are what we ought to be trying to agree internationally.
Lots of big ideas there, Simon. Thank you. To illustrate the relevance of innovation to the deployment of existing low carbon technologies, we're going to turn now to the role of offshore wind. And I'm going to turn to you, Megan, if that's okay. Obviously, it's one of the key technologies that we need to deploy further and faster. Can you remind us why offshore wind is so important for net zero?
Yeah, so absolutely. So offshore wind has a number of key advantages. The main one is its scalability. It can be deployed at scale and in an economic way, basically. So it's certainly part of the energy mix. You're not going to be deploying offshore wind where there isn't any sea, but it's huge advantages. If you compare it to, for example, to onshore wind, where again, onshore wind's a very cheap source of energy, but to make those offshore wind farms at scale, the vast amounts of land required. You don't need to use all that land, but you do need to have land agreements covering that land. And that is incredibly complex. And finding those kind of areas where you can have such huge areas of land where you can deploy at scale is very challenging onshore. But offshore, you have one landowner typically per country, per market, and it's much, much easier. You have the same kind of conditions. You can use the same technology to roll out the same sort of installations, whether you are in the North Sea or whether you're off the coast of California. So again, you have this huge global scalability coupled with a massive reduction in deployment cost that really makes it a global player.
So that's a key point, isn't it? We've achieved an awful lot in offshore wind over the last 20 years. It used to be relatively expensive as a source of electricity generation. It was a relatively immature technology. Megan, can you talk us through how innovation has helped to address those challenges?
Yeah, so I mean, to put it in context, exactly 20 years ago this year, we had the first installed commercial offshore wind farm in the UK, total capacity of 64 megawatts. In the UK, we now have 14 gigawatts, which is 14,000 megawatts. So a massive step change in the amount of deployment. And in terms of the cost reduction that we've seen in offshore wind, the installations being deployed today are sort of one of the cheapest sources of energy within this country. So those costs have come down significantly. And innovation has really, really helped drive that cost reduction and therefore deployment, because these two obviously go hand in hand. And using new technologies, using innovative ways of doing things is really crucial in that. So, for example, one of the programs we run here at Carbon Trust is called the Offshore Wind Accelerator Program. It focuses on cost reduction in offshore wind. It has been going for about 13 years now. That program alone has reduced the cost of offshore wind by 15%, saving European consumers over £34 billion. So again, like small changes in costs can have huge impacts on consumers. And I think when we're talking about innovation in offshore wind, it's really important to focus on the technology innovation, because obviously that's a huge, huge part of it. But not only the technology innovation, right? We also need to talk about the innovative ways of doing things, which is sort of slightly separate from the technology. So maybe just to give a couple of examples there, one of the projects that we looked at that we've supported is helping develop larger cables. And the reason we need larger cables to connect wind farms together is the turbine sizes are increasing massively. So again, 20 years ago, your large turbine was about 3 megawatts. Now we're looking at designing 15 to 20 megawatts. These things are massive. The scale is massive. You know, the turbine sizes we're designing now are as tall as the Shard, which is the biggest building in the UK. The technology challenge is huge. So we do need to keep up. And there's lots of sort of technology that needs to go hand in hand. It's not just building bigger turbines. You then need the bigger cables to connect them together. So one of the projects we did was helping qualify and build those bigger cables, because the market got to the point where we couldn't deploy those larger turbines because there weren't the cables on the market to actually link them together. So we helped work with 3 cable manufacturers to get them to market, and within a year we had the first planned wind farm that was at that larger turbine size at around 8 megawatts. At that stage, we've now gone beyond that even still.
So, Megan, there's been clearly huge progress in bringing down the cost of offshore wind through innovation. And you've talked about how the technology is evolving in terms of scale. But clearly, for it to reach its full potential and for us to really exploit the technology to the scale we need to achieve net zero, we need to be looking at producing and installing turbines on a sort of industrial scale. And that means making them and installing them at a much faster pace. Can you give us a rough idea of how much faster we need to be building offshore wind to reach net zero by 2050?
Yeah, so I mean, looking at floating wind specifically, for example, at the moment, we are seeing our first floating wind commercial floating wind farms being built now, and floating wind is going to be massively essential in meeting those targets, because there are so many areas of seabed that are too deep for fixed offshore wind. So at the moment, it takes around 6 weeks or so to load out, install, and fully commission a floating wind turbine at portside. We have very limited portside space to be able to do that. So to meet our targets, we need to be doing that in days, not weeks. So 2 a week rather than 1 every 6 weeks. So this is a massive step change in how we're deploying technology, how we're installing technology. The actual baseline technology that we're building might not change, but how we do it and how we deploy it. So offshore wind to date has been a massive success story. I mean, it's been a really exciting industry to be part of, but we need to change gear now, right? Like we need to do things differently, and we need to approach things differently to really make this a global energy source.
And at a high level, when you think about the innovation challenges facing this sector, how will innovation be different looking to the next, decade or more, to the decade or two that we've already had?
The real key focus is going to be on industrialization. So I would, we've seen massive growth in the size of turbines, for example. I would imagine that's going to slow down. We're not going to be increasing size, increasing efficiency. We're not going to be seeing as much new technology. What we are going to be seeing is doing things better, quicker, faster, cheaper. And we're seeing a shift in that. The last 20 years has brought a complete change in the entire industry. I think the next 10 is going to be very different again.
It would be great to turn to Lyndie now to zoom in on a very exciting and promising market for offshore wind. So the US currently only has a handful of wind farms, but has set itself extremely stretching, ambitious targets for offshore wind deployment. Lyndie, could you explain to us what makes the US such an exciting market for offshore wind?
Sure. So up until recently, the U.S. has had 7 turbines in the water. So there were 5 off the coast of Rhode Island that were built a few years ago. Relatively small 6 megawatt turbines that were the first built in the U.S. And then a few years after that, 2 were installed further offshore off of the coast of Virginia as a research site. But we have many, many lease sites in the U.S. And the first 2 utility scale projects are now under construction, which is really exciting. So in the U.S., our administration, they've set a goal for 30 gigawatts of offshore wind by 2030, often called 30 by 30. And then more recently, 15 gigawatts of floating offshore wind by 2035. So we're in the throes of building a brand new industry here in the US, which is very exciting, but also very challenging. So One thing that we need to be cautious of, that we need to do this quickly and have that balance of kind of doing it quickly, but also doing it responsibly. And so looking at things like how we consider, energy and environmental justice, how we look at environmental impacts and co-use of multiple industries offshore, and other kind of social and economic benefits. And I think there's a real need in the US as we build out to support, a robust supply chain. And I think that's a global issue, right? So it's not just the US that's increasing their development of offshore wind. It's a global problem and a global demand for limited resources. The same, vessels and crews and construction equipment are being used across the globe, and there's real competition for where these resources are going. And so I think as we look at, the bigger picture, the pace is going to go much quicker as we move forward. And we'll need to have real key innovations to support that. And I think Megan said it great. And, innovations not just in the technology, but how we approach these things. We have a lot of lessons learned from Europe that we are fortunate to build upon in the US. And we're seeing a big increased demand for local content and domestic supply chain here, and some incentives to help support local content and domestic supply chain, which has led to investments in everything from kind of training centers to port infrastructure to support this new industry. And, compared to early European development, we're starting with, 12 megawatt and larger turbines. So that's been a really interesting challenge here in the US, but it adds a lot of potential to our lease areas. We are able to benefit from that decades of experience and build in a highly advanced way, kind of from the start. I think we have quite a challenge ahead of us in the US as we build this industry, but it's also a really exciting time to be part of it.
Yeah, and you've outlined a number of challenges there that the US faces in terms of supply chains and doing this in a way that is responsible and doesn't create any unintended consequences for the environment. You also mentioned that the US has a lot to learn from Europe, and I think that's a good point outlined well by Megan as well. But of course, the US is very different geographically. It's got different weather patterns, different seabed geology, and so there's a need to adopt new methods and technologies to deal with that. Focusing in on one interesting example, we know that about 2/3 of the US's offshore wind energy potential is in water that is too deep for classic offshore wind turbines that I'm sure we've all seen photos of that are fixed to the bottom of the seabed. There's a need instead for floating foundations. Can you explain a little bit about the unique challenges that floating wind brings?
Yeah, I think that's a great question. I think, fundamentally, floating wind is just not as developed and built out globally as fixed bottom. So I think we're all kind of learning how to address this new challenge. I think, whether you're in the US or Europe or elsewhere, there's really fundamentally outstanding questions about turbine design and mooring and anchoring methods. And depending on, where you're building, each site has unique depths, unique seabed conditions, environmental conditions that all impact kind of the design of these floating structures.
That's fascinating, Lyndie. It's also very relevant to the next topic that I wanted to bring up, which was the need when we think about innovation, not just to think about the technology itself, but the enabling infrastructure required to build, install, maintain and operate it. And of course, in this case, we're talking about offshore wind. When we look at offshore wind, there are only a handful of vessels globally that can install the large offshore wind turbines that will be used in US projects. And because of its sheer scale for floating wind, particularly specialized vessels and ports will be needed. So on that, for floating wind, what will those specialized vessels and ports look like, Lyndie? Can you give us a sense of that? And how do we create enough of them?
I think I don't know if we have the answer for that yet, right? And so it's a key analysis of what do we do to build out our ports to support this type of infrastructure. And so whether it's, things like thinking about whether we need to deepen our ports to support this or look at innovative ways like using, floating barges and things like that to support what we need for floating offshore wind. I think we are thinking about that, but need to address some of these things really quickly.
Clearly some major challenges there around creating the enabling environment for offshore wind to flourish in the US, but certainly not unique challenges. Similar problems with a lack of infrastructure are seen in other industries that we need to get to net zero. Electric vehicle sales may be booming, for example, but charging infrastructure is clearly lagging behind. Simon, how important is enabling infrastructure for accelerating existing technologies that we really need to achieve net zero? And how have other sectors dealt with this challenge?
Well, I think it's almost always important, and usually there is a role for public investment, and there has been when you look at technology transitions of the past. When we moved from horses to cars, then governments helped build the roads, and when we first started having civil aviation, then governments built air traffic control and that sort of thing. So there usually is a role, which I think means we shouldn't be frightened of direct public investment where it's needed. But clearly it's good if we can mobilize private investment as well. When you look at road transport and electric vehicle charging infrastructure, you look across countries, I think you see a whole range of approaches being taken. Some where it's a lot of direct public investment, particularly on the longer distance routes. Others where, like the UK, is more at the end of letting the private sector do it and see what happens. And actually, a surprisingly large amount does come through. When people start buying the technology, there's a market out there. A market gets created for the infrastructure itself. So you do get private investment into that. But you can speed it up. You can have public investment in funds where you welcome private investment too and bring the two together. And I think you can also use regulation in very interesting ways. You can require EV charge points to be built into all new houses, into every petrol station, into every motorway service station. You can even put them into every new lamppost. And so you can use regulation in a lot of ways to mobilize private investment. I think each sector is quite unique in this respect. Expanding the electricity grid is not the same as building charging infrastructure, and that's not the same as trying to make sure you've got deep ports so that you can do floating offshore wind. But given the need for speed, I think it's well worth bringing all of those approaches at the same time.
So the issue of speed is really important, and maybe we can turn to it briefly now. Of course, for many wind turbines, take wind again as an example, and wind components are currently custom built, but we'll need to efficiently mass produce them in order to reach net zero in time. What innovative processes have you come across that are being trialled at ports in areas like assembly and installation in order to help produce offshore wind components faster and at a bigger scale?
It's probably important to note as well, there's always a tension between innovation and sort of industrialization, speeding up manufacturing process, because every time you bring in a new innovation or specialize a component for your wind farm, then you screw up the plan of trying to do it at scale and to do it the same thing again. So I was at a cable manufacturer factory in the north of England last week, where they were saying that every single cable they provide for offshore wind farms, even though they're basically doing the same job, are all bespoke.
Wow.
And so they can't serially manufacture. They have to reset up their entire manufacturing plant for each new design of cable. So if we had a standardized cable, then we can manufacture much faster, but it means that developers are going to have to make a compromise on the sort of operation and the design of their individual cables. So there is a tension there.
Let's explore that maybe a bit. It's not unique to cables, is it? That particular challenge, diversity in all sorts of elements of this is a challenge. At the moment, each turbine, I believe, requires a different type of vessel to carry it. When it comes to offshore wind, and there are currently over 90 concepts for floating foundations. That's a challenge. So clearly we need more clarity or consensus on the design of turbines and other components like you were talking about, so the rest of the supply chain can sort of follow suit and we can achieve efficiencies in terms of scale in manufacturing and improve the speed of manufacturing. But how do we do that?
So I think a lot of it is naturally done by the market forces, right? So, rewind to 15, 20 years ago, we probably had about 90 different fixed turbine foundation designs on the market. We now probably have 4 or 5 for different seabed conditions, which are necessary, right? It's been whittled down to what is strictly necessary. And that is more, we now serially manufacture monopiles as standard designs. So, those 90 designs, a lot of them aren't going to make it, to commercialization. And so there is a sort of natural market force. But I think what's incredibly important to make that process as efficient as possible is collaboration. So collaboration between the developers and the market and the innovators and everywhere in between it throughout that entire process. So that communication of understanding what the market needs and how innovation can help meet that need and fill that gap in the most effective way, rather than going down a path that might be, academically interesting, but actually not very useful for the industry.
Fascinating. And we've talked there a lot about enabling infrastructure, the right ports, the right vessels, the right cables. But we know that for many industries, scale up also involves embracing new digital technologies. And it would be great to discuss now the role of AI and automation in the scale up of offshore wind. And one very promising use of AI is actually removing the need for vessels of engineers to be sent out in deep waters to perform offshore maintenance work. We could actually have fully remote operated wind farms. Lyndie, how far away are we from that reality in the US? We know that in Australia, for instance, there's already remotely operated mines. Could we have remotely operated wind farms anytime soon in the US?
I think we're certainly making progress there. And I think it's, especially as we move further offshore, as we move into deeper water, safety is a major consideration. And, moving towards automated systems helps, reduce some of the risk of some working in these offshore, risky offshore environments. It requires a really incredibly skilled and experienced workforce to be able to work in those types of conditions. And, we're certainly both in the US and globally working to attract and train that type of workforce, but being able to monitor, assess, and diagnose, issues during the operation of a wind farm or even during the construction remotely really helps decrease risk and saves time and costs. And so at Now RDC, we've been looking at ways that we can support R&D and innovation around these. We've funded projects that contribute to remote monitoring of wind farms through things like verifying blade integrity or turbine health or creating digital twins. And so ways that we can use AI and kind of remote operation in the kind of build out of offshore wind.
Do those help to scale other existing technologies? Have you seen that done well elsewhere?
I'm sure they will. I think beyond what any of us are able to imagine or predict right now. But I think one of the interesting things will be how they help us manage the new clean energy systems, not just individual technologies. When you think about how we're going to have power grids made up of variable supply, probably at the same time very highly variable demand, then it obviously introduces a need to manage both of those things at the same time. And if we have, if our systems are able to learn about how to manage that better and better over time, that would be a strong advantage. So I think there could well be a role for AI, both at the level of national systems and at the level of household systems, where within your own house, you want your smart meter not to be actually quite a thick meter like the ones we have at the moment that just says you've spent this much money right now, but you want it to be constantly learning how to manage your EV charging, your solar panels on your roof, your heat pump and all the rest of it, minimize your costs as you go along.
Right. So for the grid, you see a future where it works smarter, not harder.
Inevitably.
Yeah. And Megan, there's an important point here, I think, in terms of the balance that we strike between AI, automation and digital solutions and actually capturing a lot of the employment opportunities that come with the net zero transition. How can we maximise the benefits and efficiencies of digitalisation without compromising on the employment opportunities?
To be honest, I see them as complementary. Harnessing sort of digital solutions, remote operations will help reduce costs of offshore wind and increase deployment, therefore increasing job opportunities. I think realistically, if we're seeing sort of remote operations of these, as Lyndie was saying, these incredibly challenging conditions, the choice isn't going to be between sort of a remote operation fixing a turbine and a technician fixing a turbine. It's going to be the choice between a remote fixing of a turbine or the turbine doesn't get fixed. Beyond that, offshore, anything can happen. We are always going to need experienced technicians that can go offshore when the unexpected happens, which it will and will continue to do. So I see it as complementary.
Excellent. Simon, you touched on this earlier. I'd like to spend a little bit more time on it, which is the role of government in all this. Clearly, potentially very significant, not just in providing public investment for innovation in technology, but also in creating that enabling environment, addressing all those challenges that we heard about earlier. You've worked across a lot of different climate policy areas in the past. With the goal of accelerating innovation in mind, what do you think are the key ingredients for effective policy making for scaling up low carbon technologies?
Well, there's always a risk when you generalize, right? But that's what I'm going to do.
Please do.
Your question.
Please do.
And I think a good place to start for governments is don't be misled by economists, because we've all heard the idea that carbon pricing is the most efficient way to decarbonize. But when you look back at any of the technology transitions of the past, you won't find a single one where it was primarily driven by taxing the old system. You tend to find again and again they were driven by investments in the new technologies and the new systems. That's what gets you up the S-curve. That's what you have to do. That's what gets you the self-amplifying effect of the reinforcing feedbacks. Whereas what happens if early in a transition you tax the old system, two things happen. One is the old system learns to operate a bit more efficiently, so like coal plants becoming more efficient coal plants. The other thing that happens is it pushes back at you because it doesn't like the tax, and it's powerful because it's the incumbent. Neither of those things help you very much. So you really want to focus on investing in the new. Now, that principle, of course, it separates itself into several different things depending on where you are in the transition. And in this conversation, we've talked about a lot of them. Very early on, governments can invest in research and development and help speed up the identification of viable options. They can do demonstrations, pilot projects, work with industry to understand what works. Then the next thing they need to do is create a niche market. And, here in the UK, we created a niche market for offshore wind, first with renewable subsidies that were demand-led. It said if you can build offshore wind, and if we believe you that it works, we'll pay you this much for each megawatt that it generates. Then you need either some form of subsidies or regulations that help grow that market quickly. So we had contracts for difference for offshore wind and auctions for those. That created a market of greater and greater scale, pushed down cost. Costs actually went down by 70% within a decade, and it went from being 3 times the cost of the market price of electricity to being less than the market price of electricity. So anybody listening to this should be aware that in the UK at the moment, the contracts the government is signing for offshore wind are subsidy negative. The industry is paying government a subsidy. Thank you very much. All of us consumers are benefiting from that at the same time as getting clean electricity. Then of course, as your clean technology grows its market share, it becomes important that you reconfigure all the other systems around it. So you expand the grid, you design your power sector so that it can handle more intermittency, you extend the connections, you do all those other things you have to do. So there are these roles for government at each stage of the transition. And of course, the final stage you get to is you can ban the old thing. And when you do that, if you've done your job well, no one will care and no one will even notice. So for example, next year in the UK, we'll ban the use of coal in generating power. And us lot, energy nerds, Carbon Trust will notice, most people won't.
Thanks, Simon. Megan, thinking specifically about offshore wind, where do you see the biggest need for policy change in order to achieve that kind of sort of industrialization, the massive scale up that we need to get to net zero?
briefly, I think the entire energy system is worth bearing in mind. The entire energy system, so the energy markets and everything, has been designed for coal and gas. It has not been designed for renewable energy. And it works okay, but it doesn't work in an optimal way. There are lots of weird quirks that renewable energy has to kind of fit itself around, and it is not optimal at all. It doesn't mean that the system works in the most efficient way technically or economically. Another area, I think, Simon just mentioned, CFDs. They've worked incredibly well at reducing the cost of offshore wind. We are now subsidy negative. However, arguably, we've now gone too far. So the latest allocation round, there were no bids for offshore wind because the cap of subsidy was set too low. And that cap was significantly below the wholesale price of energy. So what we're seeing developers going, well, I'm not going to go down the subsidy route. I'm not going to get those advantages that Simon was talking about earlier about the consumers essentially benefiting from low cost of energy. They're just going to go on the wholesale market. They're not going to go onto the CFD route. It's a real own goal, really, because if we'd increase the price, that cap to £55 per megawatt hour, say, then I think we'd have seen a lot more bids. But as it is, consumers are exposed to quite volatile spot prices that range between 50 and 150. So actually likely to be paying a lot more for that. So that needs looking at. And then thirdly, not the most trendy thing to be talking about, but permitting. Consenting and permitting is incredibly important. 10 years ago, to permit and consent an offshore wind farm took about 4 years. It now takes at least 10. If we want to deploy at scale, we need to get this moving faster.
That's a huge challenge. Thanks a lot, Megan. And Lyndie, as you're with us, obviously we've recently seen in the US the introduction of the Inflation Reduction Act, which, amongst other things, offers incentives for offshore wind development. How instrumental or important do you think the Inflation Reduction Act will be in industrializing offshore wind in the US?
I think a lot of people in the US are looking to the Inflation Reduction Act to see how it's going to support offshore wind. It'll really help support kind of supply chain, workforce development, those type of things in the US. There's also kind of funding that's coming out of the Inflation Reduction Act in the US as well. Potential for grants to help with the kind of planning and modeling of transmission, which is a major issue that we have in the US and kind of a common issue around the globe, and grants for looking at kind of interstate transmission issues and things like that.
Let's come now to the role of collaboration, which is something we've touched on in various ways throughout this conversation. And Simon, you work on the Breakthrough Agenda, which is this UN initiative to address international collaboration gaps relating to key technologies. And one of those key areas is clean power. I wonder if you could explain some of the key collaboration challenges that there are when it comes to the clean power transition and how the Breakthrough Agenda is working to address them.
The Breakthrough Agenda is a process that was launched at COP26 by 45 countries that together covered nearly 3/4 of the global economy. And they said they'd work together to try and cross the tipping points where the clean technology becomes more affordable, accessible, and attractive than the fossil fuels in each emitting sector. And how do they try and do that? Well, the process involves continuously looking in each sector to try and understand what international cooperation do we currently have, what would be most useful for us to have, and therefore what more do we need to do? What do we need to do next? So the power sector, in fact, is the sector where there's been the most international cooperation, but there's still loads that can be done. Of course, for many developing countries, the challenge is still to deploy wind and solar that we have. Many of them have a high cost of capital. Sometimes that's to do with regulatory structures in their own countries where technical assistance can help with the market reforms. Sometimes it's to do with the perceived country level risk, and there may be currency guarantees to bring down the cost of capital could be useful. So that whole technical assistance, concessional finance is one very important piece. Then looking further ahead to the question of how do we actually have fully zero emission systems, then of course one of the crucial challenges is energy storage, and there's a huge role there for countries to pilot and test large scale, long duration energy storage and share that learning with each other. Another thing I think is really interesting is interconnectors, where the business case is continually improving. People are getting
Can you explain what an interconnector is for the uninitiated?
a big fat wire cable that joins up different countries and allows electricity to move between the countries in either direction. And those have been around for a long time. The UK has plenty of them. But the business case is getting stronger and stronger for two reasons. One, countries all over the world deploy more and more solar and wind. They need every way they can get to help balance supply and demand. And the other, people are getting better at making big fat cables, and their cost is also coming down. So that's another area. And there are initiatives in Africa, in Asia, in the Pacific to put more interconnectors in place. Doing that has technical challenges, and it also has political challenges. You have to agree how to share the costs and benefits. So there's a real need for political engagement between countries to do that. And I could go on, but one more thing I'll mention in the power sector that's hugely important is in the countries, or regions, I should say, where the economies are most reliant on coal. There are places where you have the coal industry, including mining, of course, not just coal power, contributing half of the tax revenues and millions of jobs. There are places like that in China, in India, in Indonesia, in South Africa. There, I think there's a real need for the international community to help with the socioeconomics of the transition. There's a huge challenge of economic diversification, supporting people to move from shrinking parts of the labour market to growing parts of the labour market. It's not simple at all. But I think, where you have large-scale development assistance from multilateral development banks, it can help.
Well, I mean, I think we could have a whole other podcast episode just solely about coal. But sticking to offshore wind, Lyndie, you work in a highly collaborative organisation. I wonder if you could explain a little bit about how important collaboration is for addressing the innovation needs in offshore wind.
Sure. I mean, I think, one is just the formation of our organization in general. So our goal is to advance offshore wind technology and R&D, primarily through a competitive grant process. But we've been able to build this consortium, this public-private partnership of state agencies, federal agencies, offshore wind developers, power companies, other folks to kind of come together around R&D. So the formation of organizations like ours fundamentally show that there was an acknowledgement of this need for collaboration and kind of coming together. So there are places where our members compete, certainly, but there are places where they acknowledge that there's a need to be collaborative. So, we think critically how we can use our consortium to address, global supply chain, workforce development, supporting U.S. kind of needs and industry. And so I think, as we all are trying to look at these really ambitious net zero goals, there's no way to do that without being collaborative.
Fantastic, Lyndie. Thank you very much indeed. We've covered a lot of ground today, and we're out of time. So to wrap things up, I'd like to ask each of you what your top 3 priorities would be for transforming the offshore wind market in just a few words, if you don't mind. And Megan, I'm going to start with you.
Industrialization, doing things larger, faster, cheaper. Second, system integration. So how we bring offshore wind into the grid, how we balance storage and things like that. And then continued collaboration. We're doing it so well at the moment. We need to continue doing that and do that more on an international scale within the markets as well.
Lyndie, what about you? What would your top 3 priorities be?
I think about the challenges that come out a lot in our discussions. I think, one is about, supply chain. How do we scale up supply chain and how do we do it quickly, both nationally and internationally? I think that's something we really, really need to think critically about. And as Megan said, kind of collaborate on as we're all kind of answering the same questions. I think, another is how do we address our grid and transmission needs, both onshore and offshore. I think that's something maybe in the US we thought about a little bit later than we should have. And I think we're behind the 8 ball a little bit. And I think it's a key thing. And perhaps I'm a little bit biased, but the third is kind of how do we use technology and innovation to look at kind of environmental impacts and kind of coexistence. I think, granted, I'm an ecologist and I think about these things, but I think there's a really, really interesting opportunity here to use things like AI and autonomous systems and things like that to address these key challenges that we have.
Great. Thanks, Lyndie. And Simon?
Well, those are two great answers. So I have to give a different kind of answer. So I'll say the top three things would be China, Japan, and Brazil. China, of course, overtook the UK as the world's largest market for offshore wind, but I think they could probably use quite a lot more, not least because they're still planning to build 250 gigawatts of new coal plants. And there really would be quite a lot better for all of us if at least some of that was offshore wind instead, maybe floating, who knows. Japan, because obviously it's one of the world's largest economies, and they have quite a tough time. They're very constrained on space. They have lots of people. They have lots of mountains. They always tell us it's very difficult for them to deploy large amounts of solar and onshore wind. They don't have a great big continental shelf like the UK does, but they are very interested in floating offshore wind. And so that could be extremely useful for them. And Brazil, actually, I just spent all of today talking to a delegation from Brazil. They're extremely interested in offshore wind. In fact, among all the emerging economies, they've been the most successful in onshore wind. If you look at it as a percentage of their grid mix, they've accelerated that very, very fast and created a lot of jobs in the process. And now they're interested in offshore too. So I think when I talk about cooperation internationally, often I'm challenged with, well, what about competition? And I really enjoy hearing Meg and Lyndie talk about the cooperation between private sector actors within the offshore wind sector. And it's really important, I think, to recognize that cooperation and competition can coexist. And if that's true between companies, then of course it is also true between countries.
Simon, thank you very much. That's an inspiring note to finish the conversation on, and I think brilliantly sums up what we need to see happen to achieve the future for offshore wind that we've been discussing with you all here today. Thank you, Simon. Thanks, Lyndie. And thank you, Megan.
Personally, that conversation has made me feel very positive about our ability to achieve net zero. We've got many of the solutions we need. We now need to innovate so we can use them at scale.
But of course, there are other big challenges we need to address to achieve net zero, and our next episodes will focus on two more important types of innovation: reinventing business models and developing new technologies. So there's plenty more to be discussed.
I'm really looking forward to those discussions, and we hope that you'll join us. So please follow or subscribe wherever you get your podcasts, and follow us on social media for updates. Thanks for listening.
Thank you. Goodbye for now.